Today I will be explaining the physics of a guitar. But before I do that, there are some important concepts that we must first understand. These concepts are frequency, wavelength, and closed standing waves. Our first concept is frequency, which is the rate at which a vibration occurs resulting in a wave. It is often referred to as pitch and is directly proportional to the number of times a wave oscillates. This means that a higher frequency will produce more oscillations and a lower frequency will produce less oscillations. The units of measurement for frequency are hertz. Our next concept is wavelength, which is the distance between successive crests of a wave. Wavelength is indirectly proportional to frequency, so as frequency increases, wavelength decreases, and vice versa. Wavelength affects the pitch of a sound, so the closer the waves are, the higher the tone will sound. Our final concept is closed standing waves, which are also known as a node-node setup. A node is the location where the amplitude of a vibration is 0, and an antinode is the location where you have max amplitude. This system is connected or tied to something on both ends. Now that we know all the important concepts, we can apply them to a guitar. A guitar string has a frequency that it will naturally vibrate at. These frequencies are known as harmonics. The natural frequency depends on the tension of the string, which you can adjust by tightening or loosening the tuning pegs. Different strings play different notes depending on how much tension each string has, and the placement of the guitarist's fingers. The wavelength of the standing wave for any harmonic is related to the length of the string. Strings of a guitar are attached on both ends at the bridge and the tuning pegs, which simulates our node-node setup. When a string is plucked, the frequency of the vibration determines the pitch of the note. Higher the frequency equals a higher pitch, and a lower frequency equals a lower pitch. By pressing on a string, its length is shortened, and by decreasing the wavelength, the frequency is increased. When changing octaves on a guitar, we must first understand that an octave is an interval whose higher note has a frequency of vibration twice that of its lower note. An octave has a distance of 12 half steps, or 12 frets. If you're on the 1st fret, 6th string, F note, and go up 12 frets to the 13th fret, you will also hit an F note, only an octave higher. In order to go down an octave, you would just go down 12 frets. I hope you now have an understanding of how different guitar strings play different notes and how notes up or down an octave are produced. And these are some of the citations I used.